In this video, I will explain concept of frequency components compensation of the Opamp. In this video, I will explain concept of frequency compensation of the Opamp. Concept of frequency compensation of the Opamp. Consider the Opamp system with 3 break or corner frequencies. Consider the Opamp system with 3 break or corner frequencies. Op-amp is a high gain direct coupled amplifier. Multi different stages are used in op-amp construction. Stage 1, stage 2 and stage 3. Consider an op-amp system with 3 break or corner frequencies. That means 3 stages are considered. 3 stages of the op-amp are considered. Each stage of an op-amp added some capacitive effects. That is the reason 3 capacitive effects are considered. Consider 3 break frequencies. This is possible in practice due to the capacitive components produced by the various number of stages. This is possible. This is possible in practice. Due to the capacitive components produced by the various number of stages. We know that for a single stage, the open loop gain function of an operational amplifier as a function of frequency is per single stage. That is equal to AOL, open loop gain of an op-amp at 0Hz frequency by 1 plus J into F by F naught. F by F naught, where F naught is the break frequency, 1 by 2 pi R naught into some capacitor C1 or C. Consider 3 stages. For consider 3 stages, the open loop frequency dependent transfer function of such a system can be assumed as the open loop frequency dependent transfer function of such a system can be assumed as this is for a single stage. This is for single stage. For 3 stages, the open loop gain function as a function of frequency is open loop gain function of that op-amp as a function of frequencies for 3 stages. AOL of F is equal to AOL, open loop gain of that Opamp at 0 Hz frequency by 1 plus J into F by F1, 1 plus J into F by F2, 1 plus J into F by F3. F1 and F2 and F3 are the three break frequencies of the three stages. That means 0 less than or equal to F1, 0 less than F1, F1 less than F2, F2 less than F3. Where F1, F2, F3 are the poles of this open loop gain frequency dependent transfer function, that is AOL of F. See the method of modifying by using these consider these three break frequencies, draw the frequency response curve, frequency versus magnitude of that open loop gain frequency. Open loop gain as a function of frequency, this is the magnitude. Gain is constant up to break frequency. The gain is constant up to break frequency F naught. Three break frequencies. This is the first break frequency F1. After that, the gain is decreases at a rate of minus 20 dB per decade. Minus 20 dB per decade. This one is a F2 break frequency. Up to this one, minus 20, minus 20, minus 40 dB per decade. Another break frequency for three systems. Three corner frequencies are three break frequencies. Like that. This is the unity gain crossover frequency. This is 0 dB. This is 106 dB. The main disadvantage of this system is this is the uncompensated system having three break frequencies. Consider three cascaded systems. These three cascaded systems introduces three capacitive effects. Due to these three capacitive effects, the gain of the amplifier is decreases like that: minus 20 dB per decade, minus 40 dB per decade, minus 60 dB per decade. Due to more number of gain changes, gain of that open loop gain of the top amp is changes due to three corner frequencies. That is it introduces some instability. It introduces some instability. How to overcome that situation? By using compensation technique. By using compensation technique. The definition of frequency compensation. The definition of frequency compensation. The method of modifying method of modifying open loop gain voltage frequency. The method of modifying open loop gain voltage open loop voltage gain or open loop voltage gain open loop voltage gain frequency dependent transfer function transfer function response, that is magnitude response, response of the tap of the op amp so that it behaves like single single break frequency response, which provides single frequency response is called frequency compensation technique, is called as frequency compensation technique. Consider 3 stages, each stage having some break frequencies. First stage break frequency is F1, second stage break frequency is F2, third stage break frequency is F3. These break frequencies are due to 3 capacitive effects are introduced. 3 capacitive effects. Each capacitive effect is due to physical characteristics of that semiconductor devices and internal construction of that op amp. Due to these conditions, some capacitive effects are added. Due to these capacitances effects, the gain of the amplifier is decreases at high frequencies. Consider 3 stages with 3 corner frequencies F1, F2 and F3. 3 times the gain it changes at high frequency range. That introduces some instability in the op amp conditions. That is the that is the reason go for compensation. This is the uncompensation due to this uncompensation technique. Uncompensation. By introducing this compensation technique, instead of 3 break frequencies, I have to introduce 1 break frequency only. That is called as a modified open loop gain frequency dependent transfer function response. Instead of 3 break frequencies, we use only 1 break frequency. The gain decreases at the rate of minus 20 dB per decade only, instead of minus 60 dB per decade. By introducing a compensation network, frequency compensation networks, which are connected to this uncompensated op amp networks. Due to this compensated network, the gain of that op amp decreases at the rate of minus 20 dB per decade only, instead of minus 60 dB per decade. This is the, again, frequency. This one is gain, open loop gain of an op amp as a function of frequency. That is magnitude function versus frequency. This one is at F1. F2, F3. This one is crosses. This crosses the 0 dB. By introducing a compensation network, the gain of the amplifier is decreases like that, in that fashion, and crosses the 0 dB axis and meet at one of the break frequencies of that uncompensated system. One of the break frequencies. Here in this in that figure, consider F1. This is F1 is the one of the break frequency of that uncompensated system. Uncompensated system. This one is minus 20 dB per decade, minus 40 dB per decade. This one is minus 60 dB per decade. Instead of these 3 decades, we use only one decade, that is minus 20 dB per decade. The method of modifying open loop gain frequency response of the op amp so that it behaves like a single break frequency. This is called as a single break frequency, that is FB, single break frequency. Instead of 3 break frequencies for 3 cascaded individual systems, by using that introduces some instability in the op amp operations. In order to eliminate that instability effect, by using frequency compensation networks that is connected in series with that uncompensated networks. Therefore, the gain of that the gain is decreases at the rate of minus 20 dB per decade and crosses the meet the 0 dB axis and at a pole of F1, either F1 or F2 or F3. These are the break frequencies of the uncompensated network. By using this one, avoid the instability of the op amp. With this, the frequency compensation concept is completed.